the ratio of wavelengths of electron waves in two orbits is 3:5. The ratio of kinetic energies of electrons will be. So what you need to find out is, you are provided with the wavelengths, the ratio of their wavelengths. And what you need to find out is, you need to find out the kinetic energy. Now, do you know the relationship between wavelength and kinetic energy? What was that, students? It is lambda is equal to h by square root of 2 mass into kinetic energy. This was the relationship, right? Now, what can be deduced from here, students? What is the relationship between lambda and kinetic energy? The lambda is inversely proportional to the square root of kinetic energy. Okay? So, what can be done here? What we can write here? That lambda 1 upon lambda 2 is equal to square root of kinetic energy 1 upon square root of kinetic energy 2, because there is a inverse relationship. Or what else can we write here? This is lambda 1 square upon lambda 2 square is equal to square root of kinetic energy 1, sorry, it should be 2. There is inverse relationship. I am telling inverse and I am writing direct. Sorry, students. It should be kinetic energy 2 upon kinetic energy 1. And this is also kinetic energy 2 upon kinetic energy 1, right? Now, lambda 1, the ratio of the wavelengths is 3:5. Now, when we are putting the square, we should not put the roots over here. Now, lambda 1, that is your K2 upon K1 is equal to lambda 1 square, that is 3 square upon 5 square, and this will give you 9 upon 25, right? So the kinetic energy, the second kinetic energy is to the first kinetic energy, that is K2 is to K1, is equal to what? Is 9:25. So K1 is to K2 will be equal to 25:9. So what will be the answer here, students? It would be 25:9.